In today's lesson, we're going to solve linear inequalities involving one variable. We're going to be asked to write our answer in two different ways, set builder notation and interval notation. We will also be asked to represent our answer using a number line. To start, we want to make sure that we know the difference between when we use square brackets versus when we use parentheses. A square bracket is used when you want to include the end value. We're going to want to use a square bracket when we see a greater than or equal to symbol or a less than or equal to symbol. And square brackets look like this. Parentheses are used when you don't want to include the end value. You're going to use parentheses when you see a greater than symbol or a less than symbol. And parentheses look like this. Now we're going to use brackets or parentheses when we're writing our answer in interval notation and also when we're graphing on the number line. On a separate sheet of paper here, I'm going to quickly review set builder notation. Let's suppose you're solving a problem and you get this for your final answer. If you're asked to write your final answer in set builder notation, you always start with this general outline. Then in this blank space right here, you just insert your inequality answer. So we're going to put x is greater than or equal to 8. And this is your answer written in set builder notation. To read this aloud, this bar right here is read as such that. So we would say the set of all x such that x is greater than or equal to 8. Let's do one more example. Let's suppose you're solving a problem and you got this for your answer. And let's suppose the instructions tell you to write your answer using set builder notation. We always start by drawing that same outline that looks like this. And then we just insert our answer in the blank. So we're going to insert x is less than 2/3. And how would we read this aloud? The set of all x such that x is less than 2/3. Let's suppose you got this inequality for your final answer. To write your answer in set builder notation, you start with this general outline, which we just practiced, and then you just insert the inequality in the blank space, as shown here. You will also be asked to graph your answer on a number line and to write your answer in interval notation. Let's suppose you have this statement here, and you are asked to graph it on a number line. This statement is saying that x is between the endpoint 3 and the endpoint 10. Remember when you see a less than symbol? That's telling us that we're not including the endpoints and we're supposed to use parentheses. So to start, 3 is our lower endpoint, and since we see a less than symbol next to it, we don't want to include it, so parentheses mean we are not including the endpoint. And then our higher endpoint is 10. Again, since we see a less than symbol next to our 10, that means we do not want to include that endpoint. And so we'll use a parenthesis, because parentheses mean we are not including that endpoint. And then we draw a line connecting these two endpoints. So this means that x is between the endpoints 3 and 10, and we're not including 3 and 10. This visual representation on the number line means the same thing. This means that our x value is any number along this line, and the parentheses indicate that we are not including the endpoints. Now, interval notation connects very nicely with the number line representation. So let's say we have this expression here, and we're supposed to write it in interval notation. With interval notation, you always list the endpoints and separate them with a comma. You always first list the lowest endpoint, which is 3. Then we need to ask ourselves, are we including that endpoint? We are not. The parenthesis means that that endpoint is not included. So we put a parenthesis next to that endpoint in our interval notation. Once we've listed the lowest endpoint on the left, then we put a comma, and then we list the highest endpoint on the right, which is 10. Now, we need to ask ourselves, is 10 included? It is not, since we have a parenthesis, so then we have to put a parenthesis next to our 10 in the interval notation. So all of these representations say the same exact thing. This interval notation, just like all the others, says that our x is any value between the low endpoint 3 and the high endpoint 10, and we're not including either of those endpoints. Let's take a look at the next example. Let's suppose we have this expression here. To write this expression in set builder notation, we just have to remember the general outline, which is this. Once we have that general outline, then we just insert the inequality right in that space there. Now, let's graph this on the number line, and then we'll write it in interval notation. To write this on the number line, let's start with our lowest endpoint, the 3. Now remember, if you see a less than or equal to symbol, that means that we are including the endpoint 3. And we're supposed to use a square bracket in that case because square brackets mean you are including the endpoint. So we'll draw a square bracket at 3. Then we look at the highest endpoint, which is 10. Since we see that the 10 is next to the less than or equal to inequality, that means we are including that endpoint. So again, we should use a square bracket. And then we connect that. Now the number line can really help us to quickly write our expression in interval notation. In interval notation, we always list the lowest end value on the left and the highest end value on the right. Our lowest end value here is 3. 3 is included, so just like we used a bracket on the number line, we also want to use a bracket in interval notation. Then we write a comma and list our highest endpoint, which is 10, and again, 10 is included, so just like we used a square bracket on the number line, we also want to use a square bracket for interval notation. This interval notation says the same thing that these 3 notations say. It says that our x is any number between 3 and 10, and we're including the endpoints 3 and 10. Next example, right here, you can see written in set builder notation right here. Let's graph this on the number line quickly. I identified the endpoints -7 and -1. The -7 is next to this symbol here, meaning that it's not included, and so we use a parenthesis there. The -1 is next to this symbol, and so we want to include the -1. So we put a square bracket there. Now, why do these symbols mean you don't want to include the endpoint, and why do these symbols mean that you do? Well, it makes sense if you think about, for example, here. This is read as x is less than 10. So x cannot equal 10. We don't want to include 10 because x is strictly less than 10. Versus here, this says x is less than or equal to 10. So x could equal 10. So we want to include 10. Okay, to quickly write this in interval notation, I've listed the lowest endpoint on the left and the highest endpoint on the right. I see on the number line that next to the -7, we should use a parenthesis, and next to the -1, we should use a square bracket. Next example, let's suppose we want to write the inequality x is greater than 3 in set builder notation. Again, for set builder notation, we just remember this same general outline, and then we insert the inequality in this space here. Next, let's draw it on the number line. Now for these examples, they had 2 endpoints, and x was between those endpoints. Here, we just have one endpoint, and this is read as x is greater than 3. So this is a case where we see this symbol here, and we'll use a parenthesis next to the 3. And since x is greater than 3, x can be any value greater than 3, which we show with an arrow pointing to the right. In interval notation, we always list the lowest end value on the left, which is 3, and we'll put a parenthesis next to the 3 since we are not including it. Then we always list the highest end value on the right. In this case, our x values can be any value greater than 3. So this arrow is going to go off to positive infinity. So our largest endpoint here would just be infinity. Mathematicians have agreed that for positive infinity and negative infinity, we always use parentheses. That is just a rule that mathematicians have agreed upon. And we can sort of picture infinity as being an unreachable number. You can never actually get to infinity, so we can't actually include that because it's really unreachable. So we always use parentheses next to positive or negative infinity. And we'll take a quick look at these last 2 examples. This is read as x is less than or equal to 9/2. Now, when you're drawing fractions on the number line, it can be helpful to rewrite it as a decimal. And if you just compute 9 divided by 2, that gives you 4.5. So let's see. Let's find 4.5 or 9/2 on the number line. That would be right about here. And we see this symbol here. That means we want to use a square bracket. And let's see, since x is less than or equal to 9/2, we want to show our arrow going to the left. Since we want to include all values on the number line less than or equal to 9/2. In interval notation, we always start by writing the lowest endpoint on the left. In this case, the x values can go off and off to negative infinity. So our lowest end value is negative infinity. And next to positive and negative infinity, we always use parentheses. Then we write a comma and we list the highest endpoint on the right, which would be 4.5 or 9/2. And we want to use a square bracket to show that we're including that endpoint. Let's take a look at one last example. Here we see that x is any value between negative and positive infinity. When we're drawing this on the number line, since the endpoints are negative and positive infinity, we're just going to use an arrow going in the direction of negative infinity and an arrow going in the direction of positive infinity. So our graph will look like this. One other note, often instead of drawing the graphs above the number line, people will draw the graphs right on the number line. Either is acceptable. The only reason I like to draw the graph above the number line is because sometimes, especially if you're using a pencil, if you draw it right on the number line, it can be hard to see. Okay, lastly, to write this in interval notation, our lowest endpoint is negative infinity, and we always use parentheses next to negative infinity, and our highest endpoint is positive infinity, and again, we always use parentheses next to positive infinity. Now we're going to be solving inequalities, like you see here. And for our final answer, we will be expected to use the number line and to write our answers using set builder notation and interval notation. We've practiced solving equations. Equations have equal signs. Inequalities, on the other hand, don't have equal signs. They have inequality symbols like you see here. We solve equations and inequalities in the same way, but there's one big difference. When solving an inequality, if you multiply or divide both sides by a negative number, you must change the direction of the inequality symbol. This is the number one reason students get incorrect answers when they're solving inequalities, because they forget that with inequalities, if at any point you multiply or divide both sides by a negative number, you have to flip, or in other words, change the direction of the inequality symbol. We'll see examples of this shortly. So let's go ahead and solve this inequality here. When you're solving equations or inequalities, the first step is you want to look at the left side separately and simplify the left side, and look at the right side separately and simplify the right side. We can start simplifying the left side by distributing. We can start by distributing the 7 by multiplying it by the x to get 7x, and then multiplying the 7 by 2 to get a positive 14. Then we can distribute the negative 4 and multiply it by negative 2x to get negative 8x, and then multiply the negative 4 by 3 to get negative 12. Then we can bring down our inequality symbol. To simplify this expression on the right, when you're simplifying, the order of operations tell you to work inside parentheses first. If we look inside the innermost parentheses, we can't simplify the x plus 3 at this point. So now let's focus inside the brackets. We can simplify inside these brackets by distributing the negative 2. So first I'm going to bring down the negative 2 and the 5x. Now if we distribute the negative 2 to the x, that'll give us negative 2x. And if we distribute the negative 2 to the 3, that'll give us a negative 6. And then we'll bring down our plus 7x. So on the right side here, we're just focusing right now on simplifying inside those brackets. On the left, let's combine like terms. 7x minus 8x gives us negative 1x or negative x, and 14 minus 12 gives us a positive 2. Then we'll bring down our inequality symbol, And again, we're going to focus inside these brackets, and we can combine the like terms. 5x minus 2x will give us 3x. Now, we can't simplify the left side any further, so I'll just bring down the negative x plus 2. Negative 2 times 3x will give us negative 6x, and negative 2 times negative 6 will give us a positive 12. And we'll continue to bring down the negative x plus 2. And let's see, on the right, negative 6x plus 7x will give us 1x or x. And then we'll bring down the plus 12. Now we've simplified the left side as much as we can, and we've separately simplified the right side as much as we can. Now, when we're solving inequalities, our goal is to isolate x, and we want x on one side and the number on the other side. I recommend isolating x on the left. It's usually easier to then draw it on the number line and to convert your answer to set builder and interval notation if you've isolated x on the left side. So if we want x on the left side, let's subtract away this x on the right side. That will leave us with negative 2x plus 2 is less than or equal to 12. Let's subtract 2. That will leave us with negative 2x is less than or equal to 10. And now to isolate x, the last step is we want to divide by negative 2. And then we'll divide the other side by negative 2. And we're left with x, and 10 divided by negative 2 will give us a negative 5. Now hopefully the alarm bells are going off, because right here, since we divided both sides by a negative number, we have to change the direction of the inequality like this. For our final answer, we want to graph it on the number line and also write our answer in set builder and interval notation. If we graph this on the number line, let's start by finding our endpoint, negative 5. Now let's see here, this says x can be greater than or equal to negative 5. And as we said on the previous page, if we see one of these two symbols here, we want to use a square bracket. So at negative 5, we'll draw a square bracket, and since x is greater than or equal to negative 5, we want to show numbers greater than or equal, so we draw our arrow going to the right. Now to write our answer in set builder notation, we start with that general outline, which looks like this, and then we insert the inequality in this blank space here. X is greater than or equal to negative 5. In interval notation, the lowest endpoint is negative 5, and we list that first on the left. And since there's a square bracket here, we want to put a square bracket next to our negative 5. Then we put a comma and list our highest endpoint. X can be any value greater than or equal to negative 5. So this arrow is going to go off to positive infinity. So our highest endpoint is positive infinity. And as we said on the previous page, next to positive or negative infinity, we always use parentheses. Next, we're going to solve an inequality that involves fractions. Now there are several different approaches we could take here, but the approach we're going to take is consistent with what we learned earlier on in the chapter. And that approach says that when you have an equation or an inequality that involves fractions, you can get rid of the fractions by multiplying each term by the LCD. And I like to write it as the LCD over 1 because that makes it a little bit easier to perform computations with this when we're dealing with these fractions. Now when we multiply each term by the LCD over 1, the terms that we're looking for are going to be quantities separated by either inequality symbols, like we see here, or quantities separated by addition or subtraction symbols that are outside of parentheses, like we see here. So this subtraction symbol that's outside of parentheses and this inequality symbol gives us 1, 2, 3 terms here. I multiplied this term here by the LCD over 1. Next, we'll multiply this term here by the LCD over 1. And lastly, we'll multiply this term here by the LCD over 1. Now, once we simplify here, we'll see that our fractions will disappear. When we're dealing with an expression like this, if we remember our order of operations, they tell us when you're multiplying several different quantities, we're supposed to multiply from left to right. So first we should multiply the 18 over 1 times the 5/6. Once we get that answer, we can multiply that answer by the quantity 3x minus 2. Now there's two different ways we can multiply the 18 over 1 times the 5 6. When multiplying fractions, you can multiply the numerators and multiply the denominators and then simplify from there. Or we can use our canceling approach, and I'm going to cancel here because that's a little bit quicker. So let's see. We can take 18 divided by 6 to give us 3, and 3 times 5 will give us 15, and we're left with just 1 in the denominator, so we don't need to write it. So we've just multiplied the 18 over 1 times the 5 6 to get 15, and then we'll bring down the 3x minus 2. Let's use that canceling approach here as well to multiply the 18 over 1 times the 2/3. 18 divided by 3 gives us 6. Then we can take negative 6 times 2 to give us negative 12. And again, we're just left with 1 in the denominator, and then we'll bring down the 4x minus 1. And again, to cancel here, we can take 18 divided by 9 to get 2. And then we're left with 2 times negative 2, which gives us negative 4, and we'll bring down the 2x plus 5. Now we can see the process of multiplying each term by the LCD over 1 got rid of our fractions. Next up, we want to continue simplifying the left side, and then we'll continue simplifying the right side. On the left, we can distribute the 15. 15 times 3x will give us 45x. And 15 times negative 2 will give us negative 30. Then we can distribute the negative 12. Negative 12 times 4x will give us negative 48x. And negative 12 times negative 1 will give us a positive 12. And then on the right, let's distribute the negative 4 to give us negative 8x minus 20. Now let's see. If we continue to simplify the left side here, we can combine like terms. 45x minus 48x will give us negative 3x. And negative 30 plus 12 will give us a negative 18. And on the right side, there's nothing to be simplified, so we'll just bring down the negative 8x minus 20. Now, when we're solving inequalities, our goal is to isolate x, and I like to get x isolated on the left. So if I want to get x isolated on the left, let's remove this x from the right, so we'll add 8x to the right, and then we'll add 8x to the left. That will leave us with 5x minus 18 is less than negative 20. Now to continue isolating x, let's add 18. And that will leave us with 5x is less than negative 2. And the last step of isolating x is to divide by 5. Notice here, we are not dividing by a negative number, so we do not need to flip the inequality. So we'll be left with x is less than negative 2/5. Now we've isolated x and we've isolated on the left side. So to graph this on the number line, it can be helpful to convert this to a decimal. So if you just compute negative 2 divided by 5, that gives you negative 0.4. So when we're graphing this on the number line, negative 0.4 would be right about here, and we're going to use a parenthesis because we said with less than or greater than symbols we use parentheses, and we want x to be less than negative 2/5, or in other words less than negative 0.4. So we want to draw our parenthesis at negative 0.4 and show our arrow going to the left to show all numbers less than negative 0.4. And again, you can draw this line right on top of the number line if you prefer. Now to write our answer in set builder notation, we just need to remember the general outline, which looks like this, and then we insert our inequality in the blank space here. X is less than negative 2/5, or you could use negative 0.4 if you prefer. For interval notation, it can be helpful to look at the number line here, and for interval notation, we always list the lowest endpoint on the left. The lowest endpoint in this case will be negative infinity, and we always use parentheses next to negative infinity. Then we put a comma and we list the highest endpoint, which is negative 2/5 or negative 0.4. And we used a parenthesis here at our negative 2/5, so we'll use a parenthesis here as well. Let's take a look at one last example of solving an inequality that involves fractions. Remember, we can get rid of the fractions by multiplying each term by the LCD over 1. So let's first start by identifying our LCD. The denominators here are the 8 the 3, and the implied denominator here is a 1. We could write this as 9 over 1. So the smallest number that 8, 3, and 1 all multiply into would be 24. So our LCD is 24. So to get rid of the fractions, we're going to multiply each term by the LCD over 1. And what I recommend, if you have a fraction like this, where in the numerator or the denominator you have more than one piece, separated by an addition or subtraction symbol, I like to add parentheses around it. That's just going to make the later calculations a little bit more straightforward. So first I've multiplied the x over 8 by the LCD over 1. Then we'll multiply this whole term here by the LCD over 1. One of the most common mistakes here is that when students are multiplying by the LCD to get rid of the fractions, students will think that they only have to multiply the LCD by terms involving fractions. So when they see a term like this that's a whole number, they won't multiply it by the LCD. But that is wrong. In order to maintain equality, whatever you do to one side, you must do to the whole other side. So if we multiply this side by the LCD over 1, we have to multiply everything on the other side by the LCD over 1, including the negative 9. So I went ahead and multiplied the negative 9 by the LCD over 1. Next, let's do some canceling to get rid of our fractions. Let's take 24 divided by 8, which will give us 3, and we'll be left with 3x over 1, or 3x. Over here, you might be tempted to distribute the 24, and you can, but I think it's a little bit easier if you first cancel to get rid of the fractions. So that's what I would recommend. And we can do that by canceling. 24 divided by 3 gives us 8. So we're left with 8 times the quantity 2x plus 1. And then if we take negative 24 times 9, that will give us a negative 216. Now we've completely gotten rid of the fractions. Now let's just simplify each side of the equation. The 3x can't be simplified, so we'll just bring it down. Let's distribute the 8. 8 times 2x will give us 16x, and 8 times 1 will give us a positive 8, and we'll bring down the minus 216. And let's take 8 minus 216 to give us negative 208. Now we've simplified the left and the right side of the equation as much as we can. Now we want to isolate x. And with inequalities, I like to get x isolated on the left. So to isolate x on the left, I'm going to subtract this 16x from the right side, and then we'll subtract 16x from the left side. That will leave us with negative 13x is less than negative 208. And then to isolate x, let's divide by negative 13. That will leave us with x. Now we've divided by a negative number, so we have to flip the direction of the inequality. And negative 208 divided by negative 13 will give us a positive 16. So we've solved the inequality. Now we want to graph it on the number line and write our answer in these two forms. Let's start by finding 16 on the number line. Then we have to decide if we use parentheses or brackets. If we see a greater than or a less than symbol, we use parentheses. And let's see, x is supposed to be greater than 16, so we'll draw a parenthesis and we'll draw our arrow going to the right to show numbers greater than 16. For set builder notation, we just have to remember that general outline, which looks like this, and then we insert our inequality into this blank space here. And again, we would read this as the set of all x such that x is greater than 16. When writing your answer in interval notation, it can be very helpful to look at the number line. And in interval notation, we always start by writing the lowest endpoint. The lowest endpoint is 16. And we see we've used a parenthesis, so we want to put a parenthesis next to our 16. Then for interval notation, we write a comma, and then we list the highest endpoint. The highest endpoint is infinity, so we just put an infinity right here. And we know that next to positive or negative infinity, we always use parentheses. These two represent the same answer. They're both saying that the solution is any x value such that x is greater than 16, or stated this way, the solution is any x value such that x is between 16 and positive infinity.